I want to show some examples of geometric sums that are suitable if you've never seen the formula for geometric summation, and if you want to see if you can guess it from some very specifically chosen examples. This is how I usually present it in class, and so this is kind of a recap of classwork, but I change it from year to year, so it might not be exactly like um, whatever class in a particular year. So this is a great one to start with. 9 plus 90 plus 900 plus 9,000. So if you look at the partial sums, you get 9. Then if you sum the first two, you get 99. Sum the first three, you get 999. Sum the first four, you get 9999. Why are these so special? What's so cool about these numbers? They're really, well, pause the video if you want to guess yourself. Um, what's special about them is they're super, super close to even simpler numbers. That's 10 minus 1. That's 100 minus 1. That's 1,000 minus 1. That's 10,000 minus 1. And the cool thing is that these have a very simple formula for them. That's 10 to the 1 minus 1. That's 10 to the 2 minus 1. That's 10 to the 3 minus 1. That's 10 to the 4 minus 1. Huh, okay. So that's interesting because here the common ratio, the terms of this are a geometric sequence, and the common ratio is 10. This is something where if I want to generate the next term in the sequence, 9 to 90 to 900 to 9,000, I'm just multiplying by 10 each time. And so in fact, the sequence formula here is a sub n is 9 times, let's see, multiply by 10 to get like the fourth one in the sequence. I actually am just doing 3 hops from n equals 1. So I only am multiplying by 10 to the third. So a very standard thing for geometric sequences is first term times ratio to the n minus 1. Okay, so now back to the sums though. When I actually look at the cumulative and add them all up, I'm getting something that also has to do with powers of 10, but it's the next power of 10. So for example here, the last thing we summed up, this was 9 plus 9 times 10 to the 1 plus 9 times 10 to the 2 plus 9 times 10 to the 3. That ends up being the next power of 10 minus 1. So that's cool. Okay. So I really carefully contrive this to make it look as simple as possible and to get some really nice looking numbers. Powers of 10, which are recognizable instantly by their form in base 10, and things that are simple, and the main thing was that it was so close to a power of 10. Okay, so we want to go beyond that in our guessing games to get further. The next one I usually do is what if I wasn't so clever as to have started with 9 to get these beautiful things where it's 99999? What if I just started with something simpler, 1 plus 10 plus 100 plus 1,000? So the partial sums are going to be 1, 11, 111, 1111, 11, 111. Is there a nice master formula for that? Well, this is where it's really nice to have already done this example and not to try to do this one from scratch. This one was super nice, gave us a formula. Oh yeah, let me see. Let me actually just get the general formula. I forgot to do the general formula here. That's going to be 9 plus 90 plus, and if you end with a certain power of 10, like here the ending was we ended with 9 times 1,000. That gave us the next power of 10. It's got to be the next one, at least the next one, because it's got to be something bigger than 10 to the third. It's just the next power of 10, 10 to the n minus 1. So there's the general formula there. So what about here? So if you want to pause the video and guess, if you haven't seen this before, think about how you could take this example and turn it easily into this example. Well, all you have to do is divide everything in sight, absolutely everything here, by 9. If you divide all these things by 9, the terms turn into the terms of this one. The sum turns into the sum of this one. All these 9999s turn into the 1111s. And so it's going to be, you're still going to get the same final answer divided by 9. So the sum of 1 plus 10 plus 100 plus up to 10 to the n minus 1 without the 9 in front, it's the same answer, just divided by 9. Because what does this give you? 10 to the n minus 1 gives you something with all 9s in it. Divide by that by 9, you're going to get something with all 1s. Okay, so that's our second example. Okay, I want to make these pretty short videos, so part 2 we'll do a few other very standard examples.